Hi everyone, so we'll be doing stacks and queues in this video, and let me just first give you an intuition about what stacks and queues are, and they're very similar to how they work in the real life. So imagine you have a stack of books. It'll be very difficult for you to get something from the middle of the stack. Well, in the programming world, it's impossible. You cannot get an element from the middle of a stack. You can only get it off the top. So you can only get the top book. So basically, imagine something like this. Let's say this is your stack, and you've got elements or books like this. So the way it works is you can only get this element but not any of these, and not just can you not get any of those, you cannot even look at any of these elements. So basically whatever goes in first into the stack goes down at the bottom, and that's the last one to come out. So a stack is also called a last in first out or LIFO structure, which means that whatever goes in last is the first one to come out. So it's this element right here. This is the last one to go in, and that's the first one that's going to come out of my stack, and this is the only element that I'm allowed to look at. So a stack will basically have three methods. It'll have an add method, it would have a remove method, and it would have a top method, which is also sometimes called the peak method. So these are the three methods we are going to have, and out of these, when we do the add method, it always adds to the top of the stack, and when we do the remove method, it always removes from the top of the stack again. And the top method, as the name suggests, will let you see the top element but not remove it. So that's about stacks. Queues, on the other hand, work slightly differently. So whatever goes in first into the queue, so let's say I have a queue like this. I have all of these people in a queue, and there's, let's say, a ticket counter here. So this guy is going to be the first one to get the ticket and get out of the out of the queue, sorry. And if I want another person to enter the queue, he or she is going to enter right here. So that's how a queue is going to work. The addition is going to be at one end, the removal is going to be at the other end. So in case of stacks, this guy must have been the first one to enter the queue, and this guy is the first one who's going to exit the queue as well. So a queue is also called a first in first out or FIFO structure. So again, it has an add method, a remove method, and instead of a top method we have a first method, I guess. So that tells us which one the first element in the queue is, the one that's going to be removed now. So that's basically what queues are. And as far as object-oriented programming and Java is concerned, we have two really important questions that we need to answer. The first one is whether we should use inheritance or composition. So the first question is inheritance versus composition. What this basically means is we need to decide whether when we make our stack or queue, whether we should inherit from an array list or a linked list or whatever, whether we should inherit from that class, or whether our stack class should have a linked list as a member, a linked list or an array list. So that's one question that we need to answer, and I'd really like you to pay attention to why we're using one over the other. And I've already discussed the pros and cons of inheritance and composition in one of my earlier videos. If you haven't watched it, I would highly encourage you to watch it now. And if you want, you can pause the video right now and think about which one we should use and why. The why is important. So you can pause the video now. So I hope you thought about which one we should use, and of course it's a 50. There's a 50% probability that you would be right. So the answer is composition. So that's the one that we should be using here, and the reason in this case is quite simple actually. The reason is that when we use a linked list or an array list, we also have a method called get, and we can pass it an index I, and that'll get us the ith element in that list. And the problem here is that this method is, in case of an array list or a linked list, it's public. And I think I've talked about this in one of my earlier videos, but scope narrowing is not allowed during inheritance. So suppose I have a class here which has some public method, let's say foo, and I make another class and inherit this class. I cannot make the foo class private, the foo method private here. It needs to remain public. So the problem here is that, let's say you make a stack class and make it available for use. So what the user does is, the user as in whoever is using your class, so what he does is he does something like stack s, and now he's actually allowed to do something like s dot get I, and that'll get him the ith element. But as we talked just now, we cannot get the ith element of a stack, we can only get the top. So the get method is just one such example. We can also talk about other methods which are adding at an index, removing at an index, or whatever. We don't want our stack to allow any of these. So what the best practice is we create a stack class, and inside this we create a member which is a list. This could be an array list or a linked list. That's the second very important question. But I hope you understood why we are not using inheritance and we are preferring composition over inheritance in this case. So for the next question, the next very important question is whether we should use an array list or a linked list for a stack or a queue. So this could actually vary for a stack and a queue. We could use array list in one and linked list in another. What I want you to understand is that the top of the stack is something that we can choose. So we can choose the start of an array list to be the top of our stack. We can choose the end of an array list to be the top of our stack, and similarly for linked list. And again for the queue, we can choose our adding end and removing end. So again, if you want, you can pause the video right now and think about which one we should use in which case. So I hope you've thought about this, and the answer actually is that in case of a stack we use an array list. So this is for a stack, and in case of a queue we use a linked list. Let's talk about the reason for this. So when I make an array list for a stack, what I'm going to do is my end of the stack is going to be my end of the array list is going to be the top of the stack. So adding here is constant time, and so is removing from this end of the array list. Both of them are constant time, and even getting the element at the end is again constant time. The question that arises here is that, let's say I have a linked list. So in case of a modified linked list, if I'm actually maintaining the tail, and this isn't actually too much of a modification, linked lists tend to always maintain the tail of the list. So if it is maintaining the tail of the list, adding here and removing here is again constant time, and so is getting this last element. So we can add to the end, remove from the end, and get the last element all in constant time. So we can right now see no particular advantage of using an array list, but what really happens is um, that in case of a linked list, we are actually maintaining something like this, which is in case of a singly linked list, it would be something like this, where this is our data, and this right here is our address to the next node. And in case of a doubly linked list, it would be something like this, where this stores the address to the previous node. And in case of an array list, we are just storing the data right here. So space-wise, linked lists are not as efficient as an array list. So space efficiency is one thing that we need to think about. So that's why in case of a stack, an array list gives us an advantage. And another reason for this is because in case of stacks, addition and removal operations, which are also called push and pop respectively, are actually done a lot of times in succession. So in those cases, linked lists involve a lot of changing links to achieve addition and removal. In case of arrays, it's much easier to do multiple additions or removals. So that's another reason why we use array lists in case of stack. But what happens in case of a queue is, let's say I'm using an array list for a queue. So I have this array list right here, and I choose this to be the entering end of my queue, and this to be my exiting end of the queue. So this isn't really a problem because this is still constant time. I'm removing from the end. The problem is that this thing right here, the addition, is actually linear, because to add something right here, I would have to move all elements to the right, and then add to the first then add the first element of the array list. And so in case of a linked list, what happens is we are maintaining the head as well as the tail, so we've got both of these. So removing from the end is constant time, and adding to the list is constant time too. And so is getting this last element right here. So that's constant time too. So we are avoiding using the linear time right here. So that's why linked lists give us an advantage when we use when we are making a queue class. So I think I'll wrap it up with just a few terminology related stuff. So here's what I'd like you to know. So for a stack, the addition or insertion is known as push, and the removal is known as a pop. So we push into a stack and we pop from a stack. And in case of a queue, um, the addition is also sometimes called enqueuing, and this is actually enqueue, and the removal is also sometimes called dequeuing. So dequeue, sorry. So these are just some terminology that I like you to know. And another thing is I'll just summarize how we'll go about making our stack class. Our stack class would look something like this. This is my stack, which has one attribute, let's say, and that's my array list. Array list, and it'll have all of these methods. So it'll have a push, it'll have a pop, and it'll have a peek. And similarly for our queue, we would have something like this. We would have a queue, and we would have a linked list here, and we would again have three methods. So we don't usually call the methods enq and dequeue. We'll just call it add and remove. Sorry about the handwriting here. And we have a get first. So this is how our stack would look, and this is how our queue would look. And the reason why it's important to make these linked list and array list private is so that when someone makes a stack S, let's say, he's not able to do something like s dot arr dot get. That would only be possible if this ARR had been public. So we won't be doing that. What we'll be doing is making this private. So I think that wraps up the discussion about stacks and queues. You should be able to implement these on your own now. In the next video, I want to talk about something called a list iterator. So I'll see you in the next video.